I'm going to give you a couple pages here of notes or just some background, just some words that I wouldn't worry about writing these down unless you just want to have it for your notes, because you're going to go back and read these in 10 years. And you want good complete notes from your Physics 1 class. I'm mentioning conductors and insulators here just because we talk about the properties of materials. Things that are good conductors of heat are metals. Right? Things that are not good conductors are called insulators, plastic, glass, wood, things of that nature. Good conductors of heat are also good conductors of electricity. We're going to talk about this next semester for those of you taking Physics 2. So things like metals are good conductors of electricity. Plastic and wood would not be a good conductor. It works the same way for both heat and current or electricity. So I'm just kind of defining what they are, what a conductor is and what an insulator is. I'm not going to ask you to define these, it's just information about the types of materials that can conduct heat. This picture here, don't worry about writing this one down either, it's just showing you some things here about... You listen to me now, that you don't need to write it down? Or was I going too fast?
Going too fast.
Okay. I'll go back if you want it, if you need it.
That's pretty common sense in
Kind of, but if you want to write it down, I'll give that to you later. And you also need the second page of the objectives. Don't forget to get that from me. Get that from me later on, and I'll get you that other page if you want. Okay. This diagram here is in your book, and there are equations in your book for the equation for heat conduction. Don't worry about using that if you're reading. How many of you read the book?
We got books.
Yeah. For those of you who are, there are a lot more details about the rate at which energy flows through material. It depends on the conductivity of the material, how thick it is, what its dimensions are. It depends on this distance here, the temperature difference between them. We aren't calculating what that heat flow is, but these are really all other forms of Q. So when we were doing our calorimeters, we assumed that there was no heat flow through the container walls. We kept it insulated. So all the heat transfer was going through the water, the metal itself of the container, the ice with the metal we put in there, and it was all insulated from the surroundings. But there's heat loss to the surroundings. This could be a glass slab in your window, it could be anything, but there's heat flow through that material there. That's another form of Q, we just don't calculate what it is. Okay? But it's heat flow due to conduction there through a material. This might be a good picture. You don't have to draw it now, but another one you're going to see in your book. This gives you a few examples of, well, all three of them here. Okay? So when I ask you this question in the exam, I usually copy and paste that right there. So you give me examples and define these three methods of heat transfer. When you give me examples, you have to be very clear about your examples. Some examples that you give could be all three forms of heat conduction, or all three forms of heat transfer. This is conduction here again, like through the metal poker. The heat flows through this metal right here. The convection here is the rising air above the fire. Okay? And if you haven't felt that, when we go camping, or maybe when you go camping, I don't know if I'm going yet or not, you can try that out and stick your hands above the fire and see what's different. If it's hotter up here or if it's on the side. And you might feel the effect there of the heat via conduction here and how that's different than just holding your hands over here. But what other kind of heat transfer do we have when you hold your hands above the fire? What else would there be? There's still radiation. The radiation goes out in all directions. And so if you just say a fire or a pot of boiling water, that could be more than one thing. So when you give the example, you can't just say holding your hands above a fire. Tell me the rising air above the fire. That give me the example and make it clear that it is the one of conduction or convection. Radiation is here on the picture, kind of shown with the EM waves right here, but this really goes out radially in all directions. And so your hands will feel that in any of the three locations here. So be clear about those. The sun's a good example of radiation also.
An oven would be convection, or convection ovens.
Yeah.
All ovens would be.
But you have radiation there also. You could have radiation there. If you had a pot of boiling water, tell me about the heat transfer for a pot of boiling water. What kinds of heat transfer do we have if we have a pot of boiling water?
Conduction.
Conduction at what part?
The bottom, where the
And the sides.
pan sitting on the...
Okay. What else do we have?
Convection.
above, where else could it be occurring?
Off the sides of the pan?
Not off the sides, not much, because the air is gonna rise up. Where else would we have some convection?
Or would it be if you were using a gas stove and a fire underneath?
That would still, not much rising air there, that would still be kind of treated as conduction for the heat flowing through the bottom.
The handle?
The handle is conduction also, but maybe some radiation.
The heat flowing from the pan to the water?
Not from the pan to the water, but from the motion of all the water in the boiling pot. There's some convection there also from the motion of all the water in there. And then radiation could be everywhere, around it, above the fire, anywhere. So just, that's what I'm saying, if you give an example, don't just say pot of boiling water, be very clear. You could give me the exact same 3 examples here and draw this picture or show me what it is. This won't be hard, but I might ding you a little bit if you give me an example that really could be all 3 and you haven't really specified which part of that example corresponds to convection or radiation or something. So just be clear about your examples. And they're all based on your definitions that you'll know, or whether it's through the air or the gas molecules or a fluid, through direct contact here through a material like this, or radiation. Just every hot object's gonna emit radiation or absorb radiation. So the sun's a very good example of that, with being a lot of energy. But there are also equations for the energy absorbed or emitted due to radiation in your book, but we're not going to use those either. And so that depends on temperature, to the 4th power actually, and some other constants, but we're not going to use those either. Okay. So on your objectives, that was number 16. Explain by definition example the 3 methods of heat transfer. I've given you all those right there. The next few objectives, I'm actually going to skip, okay? Number 17 is just an equation and a couple of words. And number 18 is just a couple of diagrams. Now, in some ways those could be easy points, but we have plenty of information that I'm going to test you on. I don't want to add any more. I am taking away what I would probably consider a couple of easy points, but it's not that many. There was very little here that we were going to anyway. So we're just going to stop here with the unit 6. So go ahead and cross off 17, 18, and 19. The first law of thermodynamics is key to the whole entire subject of thermodynamics. And it's really just energy conservation in terms of the new variables, heat and work and energy like that. We don't take the time to kind of go through all the details of that, and I don't want to have you just memorize an equation that we're not going to use. So, we'll cut that off and stop there with unit 6. Okay? So we already crossed off a couple on the first side, but we still have plenty left over to test you on. The unit 6 part of the exam will be about the same length as normal, and I'm going to go over all the objectives like I usually do. It's going to count for about half the points in the final, but it'll be about the same kind of length, same number of problems, same style as usual for that part of the exam. Okay? I'm going to give you an in-class assignment now, just one more here over some of the things we learned about in this unit with heat. Take a little bit of time to do this, and then we'll start talking about the things we do to get ready for the final.
Is all of our extra credit figured into our grade already? So 10 points from that test thing or that
That
in-class
is in
assignment?
there already.